Howdy, K1YPP here, and today we're going to talk about magnetic loop antennas. I've been messing around with these things for a couple of years now, and my long-term goals with a magnetic loop antenna was to design something that was inexpensive, that would handle at least 40 watts or so, and would cover perhaps 3 bands. I think I've succeeded. Let's take a look at what we're going to talk about today. I have a piece of SharkBite PVC. SharkBite is a brand name. SharkBite PVC, it's about a 4-foot diameter. I think it ended up being like 12 feet of SharkBite. And I have some CPVC tubing here, and I have some CPVC T connectors, and I tie it all together with a couple of self-tapping screws so it doesn't come apart. It does not need to be glued. It's just in there to hold it all together. So here we have the basic radiating loop. Traditionally, when you look around on YouTube and so on, you'll see all these magnetic loop antenna designs where they're using vacuum capacitors. That's a really popular one. Or they're using big butterfly capacitors, and if you don't know what that is, go search on Google for it. But the vacuum capacitors are extremely expensive, even used, and it's not unusual to see many hundreds of dollars for just a vacuum capacitor. I wanted to get around that. I didn't want to get into the complexity of the vacuum capacitor because most times people have to make couplings and all kinds of mechanical configurations to get the capacitor into the circuit. And it's more difficult than it would seem because there's very, very high currents involved. So you need really, really good connections anytime you go from one section of the antenna to the other. What I've done here is taken a little bit different approach. What I'm going to show you is I have an antenna where the metallic conductor for the radiator is also the same metal that goes down onto make the capacitor. There's no breaks, there's no junctions, no soldering, no silver plating, fancy welds, brazing, none of that. The capacitor itself, in this case, is a couple of PVC tubes, and at the end of all this I'll have a list showing the part numbers that I used and so on. But the goal here is to come up with a capacitor that will hang down from the bottom of the loop and tunes very much like a trombone. This is a copper 3/4 inch tube. Inside this it says 3/4 inch PVC. That must be the inside diameter or something because it's closer to an inch. And to tune the band, you can raise the frequency by pulling the rod out, the trombone out, and that raises the frequency, reduces the capacitance. So our 40 meter band in this case is going to be with this trombone mostly slid in all the way. And we can get down to 20 meters. I think I built one that even went to 15 by pulling the trombone out. Now, to get, I can show you this one, to mount this on this hoop, in fact you could probably even use a hoop for that now that I think about it. I saw some the other day. What we do is we take some CPVC tubing, and the big box stores, most hardware stores sell this stuff. There's an adapter, and it's made for PVC, but I think it adapts to CPVC. The point is, you can put a piece of the appropriate sized tubing in here to CPVC, and then you can couple this antenna, the antenna, to the tuning rods. Ultimately, when you go to the plumbing store, you may not be able to find exactly the same stuff I have, but what you're looking for is a hoop and a way to connect the tuning trombone to the hoop securely so that it's not flopping around. Once you get to that point, you'll be ready to put on the aluminum. On previous versions of this antenna, I used standard old kitchen aluminum foil, just right out of the kitchen counter. And what I did is I wrapped it in a spiral wrap around, like so, and came all the way down to the capacitor. Well, I started at the capacitor, actually. And when I would get to the capacitor, what I would do is, this doesn't fit quite all the way around the capacitor tube, and I wanted maximum capacitance. On the very first one I did, what I did is I got to the capacitor, and then I spiral wrapped it and overlapped it on itself all the way up. The problem with that was the electrons that are flowing in the current, they didn't want to follow the spiral wrap. They wanted to jump across the little contacts between the spiral wraps. So it would cause varying SWR, static. It was very unstable. So I learned early on to come here with the foil, and then I would come off of the main loop, open the foil, and then create a situation where I overlapped the foil all the way down in a straight path. And that worked reasonably well. But it was messy right here. I could never get a nice transition from the loop to the capacitor. Really messy. Then I learned, over time, this has been an evolutionary process, I learned that when I came off here, actually I would start at the bottom, but to get from the transition from the loop to the capacitor, I would do this 45-degree angle thing, and then come around and keep a gap between the foil turns as it go down, and secure it with duct tape. And that worked pretty well, keeping the gap in there. There was a little bit of capacitance, not enough to worry about. This stuff's hard to work with. It rips easily, and if you're working on it in the outdoors environment, you can have a heck of a time trying to make this stuff stay put. I eventually found, and there are versions of this in copper, but I found that this aluminum one works just as well. I found that this one's by Nashua Corp up in Nashua, New Hampshire, but I know 3M makes a version. I have some of that around somewhere. And it's aluminum tape, and it's got a sticky back to it for plumbing work and I think for roofing and that sort of thing. The sticky back is extremely sticky. If you just touch it onto this loop, it's not going to come loose. You're stuck with it, so to put it. And I didn't really want that because you need to be able to work this as you wrap your spirals and so on. And I discovered that, well, leave the plastic backing on it, the non-sticky backing. The stickiness is underneath the blue material. And that worked out great. So what I'm going to do now is demonstrate how I wrap this entire antenna and capacitor in one fell swoop with this aluminum tape. Let's begin. Now I have Stan W9 SMR in the background here. He's doing all the filming and production work on this, so I credit him for catching this on film properly. So what I do, this tape here for some reason at the store was kind of beat up, so we'll see what happens. I pre-cut some duct tape to hold the aluminum tape in place as I move up with it. So let's see how this goes. I've done this many times, but when you're doing a video, things don't always go as planned. And you try to wrap it so it's at a 45-degree angle. You just sort of have to guesstimate where that is. It'll be around in there somewhere. So, tape. And you make a barber pole pattern basically. For now I'm just going to put it right to the copper pipe, I don't care. There. We tried some time ago, Stan and I, we tried to film this outdoors and it was a disaster. We were using the aluminum foil and I swear everyone in the neighborhood was having a picnic that day and having heavy equipment and tractors and trucks and traffic, and this is normally very quiet around here. So that's why we're in the workshop today. We wanted to avoid any of those disasters. Now wrapping this with the plastic on the back is nice because it doesn't tear very easily. This tape is very prone to tearing. And if you'll notice, I've got like a barber pole pattern here for me. You don't want too much gap because you're trying to get as much capacitance as you can here, ultimately. Oops. All right, now we come to the critical part. Now here's the transition that goes from capacitor to the main loop. And now the wrapping gets pretty easy. I'm going to put a little tape here just to keep it in place. And we can go back and adjust it later. Okay, and then we just continue spiral wrapping. You don't need this to be very close together, so you can actually spread it a little. Now this antenna, the reason I got into these magnetic loops is I live in an HOA, like many do today. Decided to .40 watt capability, reasonable bandwidth, and 3 bands. And you're going to see that this antenna is easily 3 bands. I built one that I had 4 bands. I think I had it up to 15 meters. Excuse me. And I've run as much as 100 watts. I don't have anything capable of more than 100 watts, but it's never had a problem at 100 watts, so we're good for that. I think it will probably safely handle 250. Maybe if somebody builds one, they can tell me what they find. This has more power. Takes just about the whole roll to make this, so I was expecting that. Okay. Now, we're getting down to the return trip here. Now it's going to come out on the other side of the antenna. Come down. And now we do the same thing here. Oh, I was going to keep you some flexibility here. I guess you're not going to have it. Anyway. You can see this is not terribly difficult. You could probably, if you have kids, you could probably have them do it. Or an ice cream or something. Now these tubes are about 2 feet long. I don't know, 2/3 of a meter maybe. And we'll get in there. And there you have the antenna and the capacitor all in one piece. There are no solder connections, no junctions, no bonding of any kind. Ta-da! So what we have is a continuous piece of metal starting at the bottom of the left side of the capacitor, up, around the loop, and back down. No solder, no lossy connections of any kind. The capacitor ends up having, being a butterfly, you have to divide by 2. It has about 200 puffs to a foot. So you end up with like 100 puffs for 1 foot with the butterfly effect. So there's about 200 puffs there. For this antenna, for 40 meters, you need 159 picofarads. So it's got a little more than you need. So in a few minutes, we'll take a look, we'll put the feed loop on it, and we'll see where this antenna falls. Keep watching. Here we are, completed antenna. I've, for the time being, just taken a couple of tie wraps, put the feed loop on here. The feed loop is about 5 feet of just house wiring, number 12, regular old house wire, and a coax connector. The only solder in this whole thing is on the coax connector. Everything else is freestanding pretty much. At the moment, if you look at, you can see that the trombone, I call it, is set near full capacitance, which is around 40 meters. And sure enough, if you look at this MFJ antenna analyzer, I've got it at 6.98 megahertz, which is just under the 40 meter band. It's sitting at about 1.2 to 1 SWR. Let's take a look and see how the other bands are doing. And you'd be surprised that the metal in this shack doesn't really have that much effect on resonance and all that. It can have some effect on the tune, but it's not as dramatic as I thought it would be when I got into these things. I don't know what frequency it's on. Oops, wrong way. Okay. This whole meter, okay. Well, right at the moment I'm up around 9 megahertz, so I gotta pull out a little bit more. There, it's probably too much, but it's just to give you an idea what it looks like. Okay. Okay, we're at 1.5 to 1, and it's 9.99. That's close enough to the 30 meter band. And let's see how 20 meters looks. I'll go too far here. Maybe up in there. Let's see. It's just about, that's a little high, that's 15 megahertz. This antenna will easily work on the 17 meter band. Alright, still up there, 15. There, one more. Now, In the real world outside my shack, I have a version of this antenna with a stepper motor attached. Okay, here we are right at the low end of 20 meters. And it's pretty much 1.2. So there you are, 3 bands with some aluminum tape, piece of house wiring, a coax connector, and a little PVC, and a copper pipe. Can't beat that for a cheap antenna. This antenna costs, with the copper tubing and the foil and all of that, I think it's around $20. And when you compare that to even what it costs you to put up a G5RV or any of these, it's a pretty good compromise antenna. I found the performance on mine is about comparable to the G5RV on 20 meters and not quite as good on 40 meters as the G5RV, but reasonable. Just last night, I have a version of this outside. I worked 3 stations. They were one of them Wisconsin, I think the other was Ohio, and then I ran it up to, that was on PSK 31, and then I ran it up to about 100 watts and got on CW and worked a fellow in Puerto Rico. So if you're looking to get on the air, you're in an HOA, this can obviously be put on a little tripod, a step ladder, whatever it might be. Put it on a balcony, and you're on the air. K1YPP 73. Of a butterfly capacitor. The plates over here on this side of the capacitor are not attached to the plates on that side of the capacitor. And when we look at it from a different angle here, you can see that this rotating set of plates couples the 2 outer plates together to create the high capacitance condition. And by pulling the plates out of there, we go to our lowest capacitance, which is what I'm doing with the trombone action, where instead of these outer plates, I have the 2 tubes coming down, and then the trombone is actually the butterfly capacitor plates.